All right, so just like last time when we talked about sequences and series in general, we learned that sequences is the numbers, but that the series is what happens when you add those together. So when we look specifically at arithmetic series, what we're doing is we're taking an arithmetic sequence and we're adding all the values together. So what they're showing you in this particular example is that if we say, okay, well, we're going to borrow $3,000 and we're going to pay $100 a month plus interest of $1 per month on the unpaid balance. So it says, okay, well, on the first month, $100 is paid to reduce the loan plus the interest of 0.01 times 3,000, which is $30. Then the second month, another $100 is paid, but this time our interest is $29. Since the loan is reduced by $100 every month, the interest payment actually decreases by essentially $1 each month, forming this sequence. So the first month we paid $30 in interest. The second month we paid $29 in interest. The third month we paid $28 in interest, and so forth down to 1. What we then can do is add up each one of these values all the way down to 1 so that we know how many dollars we paid in interest over the course of 30 months. If you are interested in the proof of the formula, it is in your notes and you are welcome to read through it. But the formula is actually given also on the next slide. So if we have n terms in an arithmetic sequence and we want to add them together, really what we're doing is we're going to take s sub n, that's our sum. However many terms in the sequence, we're going to divide by 2. We're going to add the first term and the last term together. This is the formula that you'll use if you are given the first term and the last term. If you are not given the first and last term, then what you'll do is you'll still take the number of terms in your sequence, divide it by 2. You'll take the first term of the sequence and double it. And then we know this n minus 1 times d, right? That's the pattern in the sequence. So this is our number of terms in the sequence minus 1 times our difference. You can use either one of these formulas. Additionally, if you take this formula and you can actually distribute that 1/2 so that you get s sub n is equal to a1 plus an over 2 times n, and really what you're doing is you're taking the first term and the last term and you're averaging them together, and you're multiplying it by the number of terms in the sequence. Okay, so let's take a look at the first example. We're going to evaluate s sub 21 for the sequence that we've been given. Now, we do not know the 21st term, so we can't use that first formula. We have to use the second formula that we've been given. So, s sub 21 is equal to n, which is 21, over 2, times 2 times a sub 1, there you go, 48, plus 21 minus 1, right, there's our n minus 1, times d. So we need to know d, and here it's -4. So we've got 21 halves times 2 times 48 would be 96. And then 20 times -4 is -80. So we still have 21 halves times 96 minus 80, which is 16. From here, I'm going to cancel this and here make that an 8. So 21 times 8 is 168. So s sub 21 is equal to 168. The next example has us use a formula for s sub n to evaluate the sum of the first 200 positive integers. So this is kind of an interesting one because the first integer, a sub 1, is 1, and the last one, a sub 200, is 200. So here I know the last term, so I can use a variation of that first formula. So I can say that s sub n, or really s sub 200, so I'll take the average of the two terms, so that's 200 plus 1 over 2, and I'm going to multiply it by n over 2, or I'm sorry, by n, and n is 200. So here what I'll get is 201 over 2 times 200. I'll cancel that, make that 100, and I am left with 20100. That's sort of how I think about it without a calculator, so that's 20,100. The last question asks us, all right, so our next example gives us that the sum of the first 15 terms is 345, and it gives us the 15th term of 65, so we have to find the first term and the difference. This is a two-step problem. So the first step is to find a sub 1, and we can do that using the first formula that we use. So s sub n, being 345, is equal to n over 2, right? So 15 halves times a sub 1, what we are looking for, plus a sub 15, in this case, 65. So the first thing that we'll do is we will get rid of this 15 halves by multiplying 2 15ths on both sides. So then on the left side of the equation we have 46 is equal to a sub 1 plus 65. Subtracting 65 from both sides, and we find that a sub 1 is equal to negative 19. Now that we have a sub 1, we can find d. Now the only way to find d is to use one of our other formulas. So remember that we have the formula that a sub 15 is equal to a sub 1 plus 14d, right? Because 1 plus 14 have to equal 15. So a sub 15 is 65. A sub 1 is negative 19 plus 14d. Add 19 to both sides, and we get 84 is equal to 14d. Dividing 14 on both sides, and we get 6. So this problem took multiple steps. We have a sub 1 at negative 19 and d at 6. All right, this next slide is really just showing you that if you have a summation in this form, and d and c are real numbers, then you can evaluate these using the formulas that we've seen. So it's just one of those things to remind you that you have to have your summation given in this linear form, and both your difference and your starting value have to be real numbers. So you can use the summation notation and calculator functions to solve these sequences. So what you have to do is start with second stat, and you're going to go all the way over to math because you want to sum, okay, which is option number 5. And you're going to take the sum of a sequence. So you go back to second stat and over to ops, and sequence is also number 5. Now from there, you guys see that? I know it's not awesome. Yeah, that's not awesome. So from there, you're actually going to put in your 5i minus 10. So 5, and then remember it's alpha I minus 10, comma. You're going to give it your variable of I. Your starting value in this case is 5. Your ending value is 12. And you also have to put in that you're counting by ones. Close your parentheses, and we find that the summation here is 260. Let's take a look at the next one. So I'll clear out my calculator. Second stat, all the way over to math, because we're doing a sum. Second stat again, this time we want ops, and we're taking the sum of a sequence. The sequence is 8 minus 2k, so that's second, not second, alpha and k, comma, tell it your variable is k, tell it that your first number is 5, and that your ending number is 10, and that you're counting by ones. And we find that the summation on this is negative 42. So this one was 260. This one is negative 42.